In this video, I will discuss this is a very short video about the yesterday I have taken the online class. So there were some questions asked by you. Although there were very few students who came there. So the thing is that why this thing means this is a black body chamber. This is a black body chamber like this. This thing is made here like this. What is the use of this thing actually? This is nothing but to prevent complete reflection. I mean, suppose if this was not there, what will happen if light is falling in this direction? What will happen? It will be directly reflected back like this, and no light will be present in the cavity. Okay, so it will be reflected back. So what will happen? I mean, the purpose is not solved. So if the light is falling here like this, what will happen? It will be reflected like this from here, and then there will be multiple reflections like this. Okay, so if it is falling here, there will be multiple reflections like this, like this, like this, like this. So multiple reflections. So to prevent complete reflection, I mean, so this thing is kept there. Okay, so the next topic is the standing wave. Next topic is the standing wave. That here the standing waves are produced. Now, why the standing waves at the ends, at the walls? Why always there will be like nodes? That is, the displacement will be zero. Why? Okay, the reason behind this is that see I mean, this is the you can prove it mathematically, you can prove it physically also. Okay, so say E at the walls must always be zero. That is, the electric field at the wall, they are electromagnetic waves only. So E at the walls must always be zero, because on the walls the parallel component of E vanishes, and if E was non-zero, okay, then the E would impart energy to the cavity walls and lose energy itself. So again, we don't want that. Okay, that is, I mean, this is in equilibrium. Okay, so if I mean if this is not zero here, what will happen? If it is not zero at the walls like this, if it is not zero at the walls, if it is like this here, it is like this, then what will happen? It will I mean, it will lose energy in the walls. Okay, I mean, first of all, here at the walls, at the ends, these are the boundary. At the boundary, the parallel components, this is the electric field has two components: parallel component, this is perpendicular component, and parallel component. Parallel component always vanishes. This is the condition of electric field. The parallel component of electric field always vanishes at the walls. Okay, so parallel component will vanish, and perpendicular component, see here, means it how it is looking, means it is like this, it is coming out like this, it is coming out like this. Okay, but if I mean, like, if there wouldn't have been zero displacement here, then what would happen? There would be this parallel component. This is not here. It is the condition is violated. Always remember that parallel component of electric field at the here will be always zero. Okay, it will always be zero. So I mean, this and other thing is that if E was non-zero, then what will happen? If E was non-zero here, then it will impart energy, means it will lose energy. The electric field will collide with the wall and lose energy, and so I mean, and lose energy itself. Okay, so again the purpose will not be served. So that is why here the electric field at the, I mean, the nodes are always there in the walls, because there will be, if the node is not zero here, there, I mean, it will lose energy, it will dissipate energy. If the node is not zero here, it will dissipate energy by colliding with the walls, it will dissipate energy. Okay, and then you can prove mathematically also, you can prove it more clearly. So how you can prove it mathematically? So what is the equation here? The equation is this thing, that is equation of standing wave is y is equal to a sine k vector dot r vector. So if you take it in the x direction, what will write 2 pi by lambda into x cos of omega t. So now what is the condition of node is what? Condition of node is y is equal to 0. So this 0 is equal to sine of 2 pi by lambda into x. So what will be that? Sine of 2 pi by lambda into x is equal to sine of n pi or m pi, whatever, where n is equal to 0 plus minus 1 plus minus 2, like this. Okay, so for n is equal to 0, what will you get? 2 pi by lambda into x is equal to 0. So x is equal to 0. So from here x is equal to this is x. Okay, so this is x is equal to 0. So from here you definitely get that x is equal to 0. You get yeah. Okay, then you get that n is equal to 1. Then n is equal to 1, that is this is for the first, that is for n is equal to 1, what will you get? 2 pi by lambda into x is equal to this pi. So x is equal to lambda by 2. X is equal to lambda by 2. Okay, so x is equal to lambda by 2. So I mean x is equal to lambda by 2. So from here what do you get actually? What is this? I mean this if you take this wave is how does it look like? Like this. Okay, so this entire thing, the one complete wavelength is how much? This much is actually one complete wavelength. Okay, this much is actually one complete wavelength. Actually I have not drawn it properly, means it will be here somewhere here it will be. The total wavelength is, this is the total wavelength, na? Like this. So here you are watching only this much part you are watching. So if you take it here, this total wavelength is this. So from here what do you get? That x is equal to lambda by 2. So so lambda by 2 will be what? Lambda by, if this much is lambda by 2 will be, this much will only be lambda by 2. So at lambda by 2 definitely we will get, that is for n is equal to 1. This is n is equal to 1 only. This is n is equal to 1 only. For n is equal to 1 you will get the node 0. So definitely it is proved here. And another thing is that I had directly written the solution x is equal to y is equal to a sine k vector r into cos omega t. Where from I got it? So this is standing wave, I mean the electromagnetic wave. What is the equation of electromagnetic wave? This is the equation, del square E is equal to 1 by c square del 2 E by del t2. This is the equation of electromagnetic wave. If you solve this equation, you come to actually this equation. Okay, if you solve this equation you come to this equation. So this is the thing. Okay, then comes the next point, that is yeah, this one. Okay, so what do you have to calculate? You have to calculate the basically this n nu d nu you have to calculate. I mean this u nu d nu is the energy density of radiation is n nu d nu, that is number of standing waves or number of oscillators within the cavity multiplied the average energy of each standing wave or oscillator. So n nu d nu you have to calculate. So how will you calculate n nu d nu? You will calculate n nu d nu is what? N nu d nu is actually the number of, see, n nu d nu is actually the number of, see, what are you doing here? The energy density, that is u nu d nu, energy density of radiation, that is the amount of energy per unit corresponding to the radiation with frequencies lying between nu and nu minus nu. That is the energy density the energy density of radiation lying between nu and nu minus nu is what? U nu d nu. Okay, that is equal to n nu d nu into epsilon. Now what is n nu d nu? Actually n nu d nu is the number of standing waves per unit volume, or the density of electromagnetic waves, or the number of oscillators per unit volume in the frequency range nu and nu minus d nu. Okay, so you have to calculate this. So how will you calculate this? You will calculate it like to make it simpler, you will I mean, as I had said, that all possible standing waves can be represented at the lattice point in the positive octant of the space whose axes are nx, ny, nz. So you consider a sphere. Whose radius is actually n. Okay, you consider a sphere whose radius is actually n. Okay, so you draw a sphere having radius n like this. Okay, then you take a small length dn. Okay, you take a small length dn, you draw another sphere. Okay, so what will be this n nu d nu? N nu d nu is the number of oscillators lying within the frequency range nu and nu minus d nu. What will be that actually? That will be the volume of actually this space. That will be the volume of this space actually. The number of oscillators lying within the frequency range nu and nu minus d nu will be actually this one. Okay, so you have to basically find out the volume of this thing. Okay, and another thing is that this number of modes. Okay, the number of modes can the number of modes are basically the, I mean, positive values. That is the magnitude. It can never be negative values. Okay, it can never be negative values. Okay, so you have to take the only the positive values. So what will you do? You have to take the volume. First of all, what will be the volume of this space? Actually, it will be 4 pi n square dn. Okay, you can do it. I mean, just if you do the volume of this sphere with radius is how much? 4 by 3 pi n cube. Okay, and volume of this sphere is how much? That is 4 by 3 pi n plus dn whole cube. And volume of this space will be what? 4 by 3 pi n plus dn whole cube minus 4 by 3 pi n cube. That will be the volume of this region. Okay, so that will come out to be 4 pi n square dn only. Okay, now why am I doing 1 by 8? The reason behind this is that you have to take the positive values of n. Now see, this is in three-dimensional space. Okay, now you see here I have written that in two-dimensional Cartesian coordinate we have 4 quadrants, but in three-dimensional coordinate system three-dimensional coordinate system can be divided into 8 octants actually. Okay, two-dimensional system can be divided into 4, three-dimensional system can be divided into 8 octants, where only the first octant contains all the values nx, ny, nz as positive values. Okay, so the volume of the sphere only in the positive octant will be what? Definitely it will be 1 by 8 of the volume of this. Okay, so that we have done. Okay, so that is the n nu d nu. Okay, so then we have done all this. That is here. Then this is 8 pi a cube nu square d nu. A cube is nothing but the volume. Okay, a cube is nothing but the volume. So we have divided by volume to I mean we are taking the density, na? That's why we have divided by volume. So this will be the actually the I mean this portion of the sphere. Try to imagine it in 3 dimension. Actually you are finding out the volume of this region. Actually this region you are finding out. So that will be 4 pi n square dn. Now since you have to take only the positive values, and there are 8 octants here, so only the first octant you have to take. That is why you are dividing it by 8. So 1 by 8, 4 pi n square dn. So and you will get this thing, that is 8 pi a cube nu square d nu, and So you are dividing by a cube. The reason is that you are wanting to get the density. Okay, you are wanting to get the density, so that is why you are doing this. So ultimately from here you get u nu is equal to 8 pi nu square d nu epsilon a by c cube. N nu is 8 pi nu square d nu by c cube. So if you multiply it with kt, the 8 pi nu square d nu by c cube into epsilon a. Okay, so and this is the equipartition theorem, and equipartition theorem states that the energy the energy corresponding to 1 degree of freedom is half kT. So in case of this oscillator, it has got actually 2 degrees of freedom. Like if you take the simple harmonic motion also, it has got 2 degrees of freedom. So for 2 degrees of freedom, that is, what will the total energy? It will be half kT plus half kT, that is kT. So that is why epsilon is kT. Okay.